Okay, so I'm back, and we today are going to talk about correlation. Okay, and correlation is a number. Okay, so it's a descriptive statistic. It measures the linear relationship between two quantitative variables. And what's key is that it measures the linear relationship. So the symbol for this descriptive statistic is baby R. Capital R means something totally different, so the symbol is baby R, and it is bounded between -1 and 1, where -1, that's an arrow, -1 is perfect negative correlation, and this means perfect positive correlation. That rarely happens, okay? If R is 0, that means there is no correlation. Okay, so what I'm going to do is I'm going to give you some pictures so we can kind of look at it from a scatter plot perspective. Okay, so here's a scatter plot. Of two variables, x and y. Here's a scatter plot. Okay, of x and y. This scatter plot that I put up for, and I'll do one more here. How about I do Okay, so these are the scatter plots of kind of three different situations. This situation has positive correlation. This one has negative correlation. And this one really has no real correlation. So these are sort of extreme examples. As an example, you could maybe say that this is where R equals, I don't know, 0.8, maybe. We don't know exactly because we haven't calculated it. This is where R might equal -0.8, and this is where R would equal 0, where there's no correlation. Maybe it equals 0.2. That's very close to 0 with no correlation. So the bounds between -1 and 1, that means that if R equaled -1, your scatter plot would look like this. It would be a perfect negative slope line. So it would mean that your data is perfectly linear, and perfectly negative linear just means it has a negative slope. The correlation coefficient R does not equal the slope of the line. So don't think that this means that this line right here has a slope of -1. It just means the correlation between x and y is perfect in that if you drew a line through the data, you would get a perfectly straight line. So from a graphical perspective, we can see that correlation is pretty easy to spot with respect to the scatter plots. R, of course, is a number, and it has a pretty insane formula because of the fact that you're relating two variables together. Okay, so R is equal to 1 over n minus 1, the sum of, you take x minus x bar over the standard deviation of x, and you multiply that by y minus y bar over the standard deviation of y. So what you would do is it gets very complicated. I want to show you now that we are going to use software to compute it. Okay, so what I'm going to do now is I'm going to move the lecture over into StatCrunch. So I'm in a class that I teach, and I'm here in StatCrunch, and so I'm going to click on StatCrunch. And what it does is, I need to erase this just real quick, this little arrow. What it does is it allows you to open up textbooks. Now, I may be in a different textbook than you're working in this semester, so don't pay attention to that. It's mostly about how to use StatCrunch. All my online classes use it. So what I want to do now is I'm going to make up some data. And so this data that I'm going to make up, I'm going to write up here, is about the number of cigarettes smoked per day. That's what x is going to equal. And y is going to equal number of days absent in a year. So we want to know, is there a linear relationship between the number of cigarettes a person smokes per day and the number of days absent in a year? And I'm going to give you some of the data. I'm going to type it in and show you sort of how to use StatCrunch if you haven't used it a lot. So here are my data points. And what you can see is I have people who have smoked no cigarettes per day versus all the way up to a full 3 packs a day. So it's a big range of sort of smoking habits. And then the number of days absent ranges from 1 day absent, 8 days, 4, okay, so I got my data in. Notice that X and Y match. There's both 12 data points in there. And what I'm going to do now is I'm going to go up here to statistics and sort of understand a little bit about what's going on with these stats. So the first thing I'm going to do is I'm going to go to the summary statistics, and I want the summary statistics for the columns, because this is X and this is Y. And so I'm going to have my columns, and I'm going to take var 1 and var 2, and I really want the n, means, variance, standard deviation, and standard error. Okay, so what I'm going to do now is I am going to hit compute. And what you can see is here comes my summary statistics. You can see that there's 12 data points, which we see 12 data points right here. The mean of X is 24.75, so that's the average number of cigarettes smoked per day out of all these people, and that the average number of days that people missed coming from this column is 8.75. That calculated the variance, it calculated the standard deviations, and it also calculated the standard errors. These standard errors right here are the x minus x, erase, is x minus x bar over sx for that one. And this one, I'm going to close this real quick, that is the y minus y bar over s sub y, and it's adding all of them up. So it's doing part of that calculation inside the regression calculation for you. I just wanted to show you that we can get summary statistics here. So what I'm going to do now is sort of erase a little bit of this so I can get a bit more going on here. Okay. So I want to go to the graph because it's always key to do a scatter plot first. So I'm going to scatter plot these two, and my x's are going to be my variable 1 is x, and my y variable is variable 2. It doesn't matter how you really graph it at this point, but leave all these blank at this point. You're not there to try to understand those. Okay, and we can see here's our scatter plot, and it looks kind of linear, right? The data seems to kind of trend upwards. So we do expect a positive correlation coefficient. So we know from the graph we have positive correlation. And you can go to a meeting and sound smart that once you see this sort of linear, positively sloped trend, that you have positive correlation. So what we want to know is, what is R? Like, what is that exact correlation coefficient? So I'm going to close the graph, and I'm going to go here to stat, where I go here to summary stats, and you can see that it's just a descriptive statistic. So here it is, correlation. And so we're going to take the correlation of those two variables. All what I did was highlight and check them. And I'm going to find it, and there's the correlation coefficient. So we just found R to be that number, which is, I would say, it's positively correlated. Your book might go into and want it to say very correlated or highly correlated or strongly correlated. At this level, I don't want you to put so many adjectives in front of that word, because typically if R is greater than 0.8, we say very high correlation. If R is bound by 0.5 and 0.8, we say high, and etc. But I don't want you to worry so much about the adjectives. I just want you to know that because this is a positive number, it's positively correlated. That's what I'm key for you to do. And if we go back to the formula, all what the software is doing is computing that formula, which I don't think we need to go into you computing by hand, because we have all this fantastic, wonderful technology to do it for us. So that's a little bit about correlation. I want to do a bigger data set. Now, you may have this data set in front of you, or you may not have this data set in front of you, depending upon which textbook you're in. So what I'm going to do is erase my screen where I've written all over it. Isn't this fun? What a fancy screen I have. Fancy screen, erase, 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 erase. Okay, and I'm going to close that, and I want to deal with this data set right now. And there it is. And what you can see is that this data set is huge. Not that huge, but it's twice as big as the last data set. And when we do this, I would never, ever, ever want to compute this by hand. it would be just a painful experience, and we have this fancy technology, so let's use it. Let's do the same process. First thing you want to do, number one, is get the graph. You want to know what this looks like. And you want let's kind of understand the data a little bit. We have the weight of the car. Just a second. We have the weight of the car and the mileage of the car. We might think that heavier cars get less gas mileage. We might think lighter cars get less gas mileage. We're going to graph it so we can get an idea of what we think. You're going to have your hypothesis in your head, but now we're going to check it out. We're going to scatter plot. The X column is the weight. The Y column is the mileage. I'm going to compute it, and you can see, whoa, look at that. So it is really negatively correlated. Look how tight that relationship between those data points are. So if I was me, being the statistician that I am, I would say that that's really negatively correlated, highly correlated. I don't know, I would use some kind of adjective, but for you, it's negatively correlated. So that's our scatter plot. Let's just keep it in mind over here. I kind of have to erase some stuff as we go along because of my fancy screen. And then here I want to go to the stats, and if we go to the stats in the summary and we look at the correlation of these two variables, that is the correlation coefficient, and this number matches this picture very well. We expected the negative number to come out because of the negative trend going on in this data. We expected it to be somewhat close to 1 because our data points are really like tight together, not spread out into like a wide range. So that's how we express the correlation coefficient using our software in StatCrunch. And what you can say is that weight of vehicle and miles per gallon are linearly related. Lots of things can be non-linear related. You're not ready for non-linear stuff. So we're going to deal with the linear related variables. And the next set of lectures is going to talk about how in the world do we fit a line to this data. And that line, we get that line through linear regression. So I'm going to talk about that next.